Dear students, good morning. Last class we discussed about thermal systems, and that means what are the characteristics of the thermal system, and how do we represent the thermal systems into, the liquid systems into mathematical models. So today we will see another system like thermal. So thermal system generally comprises a thermal element like heater. So how do you heat that element? So if you apply any steam as input, steam flow as input, so that the heater element is heated, and thereby the surrounding water or any liquid that is to be heated. So that what happens, the temperature within any tank or within any chamber that is rises. So in order to increase the temperature, we are using a thermal system. So thermal system generally comprises heat element and a tank. The tank has having inlet and outlet. Inlet and outlet. Inlet means here input flow rate. Outlet means output flow rate. Isn't it? Sometimes if it is water in a tank, no need of any mixer element like stirrer. But if it is any other than the liquid, say if it is liquid, you can also use if required. But other than the liquid, if it is any any chemical compositions, if it is a chemical plant, chemical industry, we need to have a stirrer. Stirrer nothing but a a device or element for using for mixing all this chemical compositions. That's the meaning of stirrer. So within a tank, you observe the diagram. Observe the diagram. In this diagram is a complete tank, inlet and outlet. This is called heater element, heater input rate. So in this tank, we are using a stirrer for mixing purpose. So that when you apply any steam to this element, the heater is heated, thereby inside this tank, the uh, the water or any liquid or any chemical compositions temperatures simply increases. Simply increases. But our as an instrument engineer, with this available thermal system, our main aim is to maintain the temperature within the tank. That is our main task. So you can maintain temperature within the tank as constant, or sometimes you can do one thing. You can maintain the output flow rate as constant. Output flow rate as constant. That is in our hand. Okay, and sometimes you can also maintain the outlet temperature. Outlet temperature. That means at the outlet of the tank, we have other temperature, but we cannot say exactly the temperature inside the tank is not maybe equal to the temperature at the outlet of the temperature, outlet of the tank. We cannot say exactly. That will be different. The temperature inside the tank may not be equal to the temperature at outlet of the tank. So, as an engineer, you can also maintain the temperature at outlet of the tank. You can also maintain one issue. Or sometimes you can also do, you can maintain the head or liquid height in a tank as constant. That is your issue. So there are some variables available in any system. What parameters you are going to maintain as constant, that depends upon our requirement. Our requirement. Say for example, I am the engineer. You are also engineer. Say for example, I am focusing on liquid height. I mean liquid head in a tank. I have to maintain as constant as set point. And somebody, say for example, you are the instrument engineer. That your requirement is the temperature within the tank as constant. Somebody requirement is temperature at outlet of the tank. Of course, see, as per our requirement, we want to do it in the process control. These are all comes under process control. Why it is meaning of process control? We want to control one parameter as constant or other parameters are constant by varying the remaining, by varying the manipulated variables. That is our main issue. And today our class is thermal systems. So thermal system generally composed of like this. Basically thermal element. Basically thermal element like heater. So how often we heat this heater? If you apply heating input. How do you apply heating input? That is with the help of steam. Steam as heating. So with some other sections in the plant, take that steam as input with some flow rate value, you can apply it is heated, remaining process is going on. See, in this let here the tank having inlet and outlet, we are representing like this. Let HI be the heat input rate, and theta be the temperature of the liquid at the outlet. See, we are assuming the heat input is rate is HI and outlet tank temperature is theta. Outlet tank temperature is theta. We are assuming, representing like this. The mathematical description of this system can be obtained by expressing the heat input rate HI in terms of two quantities. We can convert the total system in terms uh, of mathematical equations by considering some parameters H1 and H2. What is H1 and H2? H1 is amount of heat stored in the tank. That is nothing but comes under maybe through inlet, and H2 nothing but amount of heat responsible for temperature theta. It is the parameter we are considering from outlet, tank outlet. So from the tank inlet we are considering H1, from the tank outlet we are considering H2. So after consideration, next slide one. After this consideration, yes. So we can write the how this how this thermal system will relate all these parameters. How they are interdependent all these parameters. If I want to write the relation between theta and other parameters, if I want to write H1 and other parameters or H2 and other parameters, so there is a governing equation. Governing equation. I am writing like this. See, H1 depends on like this. Capital M into S d theta by dt. This is standard relation because of our structure, our tank, and our possibilities: water, steam, inlet, outlet, temperature. By considering all these, I am writing H1 equals to ms into d theta by dt. What is M? M nothing but mass of the liquid in terms of kilograms. Mass of the liquid. How much liquid is there in your tank? That is in terms of kilograms. That we have to consider. Don't leave the water. Don't leave the liquid. Don't leave the other elements. In the place of liquid, it may be gas. And we will see later about gas systems. No problem. I'm sorry. You should consider the mass of the liquid in terms of kilograms. And one more, S refers to specific heat. What is the specific heat from this heat element you have to consider? That is called S value. You know, H1 is nothing but from the inlet of the tank, inlet into the tank, and theta is the considered at the outlet of the tank temperature. Now we can define thermal capacitance C. Thermal capacitance C. Yesterday we discussed about the system, liquid system will give us the two parameters, resistance and capacitance. Resistance through some control wall, the wall where we are going to control the flow rate, so that will give us the resistance value, and the capacitance will give us from the surface of the water tank. I mean, surface of the water in a tank. So that will give us two parameters, resistance and capacitance. Here also we are defining for the thermal system, thermal capacitance and thermal resistance. These two also we have to define. But how do you get thermal resistance? The thermal resistance is from outlet temperature, outlet of the tank. You may get thermal resistance. And from the surface of the water in a tank, you can expect thermal capacitance. So again, two parameters here also we have to consider. And we define this thermal capacitance C equals to capital M into S. You know M and you know S. Yes. And see, we substitute M, substitute that value in the H1 equation, we can write H1 equals to C into, because M equals to, we can write H1 equals to C into d theta by dt. And we are defining H2. H2 equals to small qs theta. Qs theta. What is Q? Outlet flow rate in terms of kilograms per minute. Output flow rate. Outlet flow rate. So at the second side of the water tank, we are going to consider the Q value in terms of kilograms per minute. And theta, you know, temperature of outflowing liquid. That is the second side of the water tank. Fine. So we are defining H1 and H2. Our main aim is how this theta means temperature of the outlet flowing liquid depends on other parameters. Thereby we are representing a mathematical model and block diagram. We want to represent, that is our main aim from this thermal system. Right. Now define thermal resistance. This about comes under thermal capacitance. Next define thermal resistance. Resistance can be write R equals to 1 by Qs. 1 by Qs. And define and what substitute R value in the H2 equation. What is H2? H2 equal to Q as theta. In the place of Q, you write 1 by Rs. You can write H2 equal to theta by R. This is nothing but the relation between H2 and R nothing but thermal resistance, which is we are expecting from the tank second side, output flow rate side. And we can also write the substitute H2 equation in the H1 relation. We can write HI equals to, I'm sorry, we substitute H1 and H2 in the HI equation, HI. So we can write C theta by dt plus theta by R. And for this above equation, multiply with R on both sides. You may expect R into HI equals to RC d theta by dt plus theta. Apply Laplace transform. Next slide. Apply Laplace transform. Yes. If you apply Laplace transform, you know what happens. R is same as T, and HI is nothing but capital HS, HI into S. R equals to R C is as T, but d theta by dt can be write S into theta of S plus theta of S. You can take the combined theta of S common, you will get 1 plus RCSS into theta of S. From this, you assume time constant T equal to RC, then substitute and write theta of S by HI of S. What is theta of S? Theta of S is the output temperature at the second side. You can consider this output. What is HI of S? It is the input. Output by input is what transfer function. Transfer function we are writing capital R by Cs plus 1. You can represent the same as block diagram representing input and output, in between representing a transmittance or gain. This is your mathematical system of your thermal system. Thermal is very simple. Very simple. Only you have to what are the parameters we are represented in the considered thermal system and how we are going to define respective capacitance and resistance from the system, then substitute it, apply Laplace transform, rearrange, you may get mathematical model and block diagram. It is very simple system. Okay. Next, next system. Next system. So we covered right now yesterday liquid systems. It's also called hydraulic systems, liquid or hydraulic system. Sometimes you can also have hydraulic system. And today we see thermal systems, and we see one more topic: gas systems. Gas systems. Gas systems also called pressure systems. Pressure system. So what is there in this system? But in the liquid systems, liquid is provided. Liquid is provided in the tank. In the thermal system, of course, liquid is provided, but major element is heater. In the thermal system, heat element is provided with the help of steam input. Fine. But in the gas system, you tell me what is gas system? Gas is input. The system comprises gas, it accepts the gas input. That system you want to consider and you want to write a mathematical model. You want to represent that mathematical equation. That's nothing but gas system. Understand my point? Gas system nothing but is a system which works on gas input. So if you apply gas as input, it is similar to the other system what we discussed today and last year, tomorrow, I'm sorry, yesterday. We have to consider again two parameters, the corresponding resistance and capacitance. And you write the governing equations, substitute in that and rearrange what parameter you want as you have to understand the relation, represent it and rearrange it, apply Laplace transform, you can get the corresponding mathematical model of the gas system. Right? We will see in the gas system there is a chamber. So gas system is a complete envelope. It is a pressure vessel. Yeah. It is a complete closed vessel. See, at one side it is opening, no second side. Remember, understand the difference, my dear students. Understand the difference between liquid system, thermal system. In the liquid system and thermal system, there are two openings. There are two openings, but here we don't have second opening in the gas system. In the gas system, we have one opening and there is no second opening because we are provided here pressure vessel. Pressure vessel is a closed vessel. Is a closed vessel in the second side. The first side, input side, we are applying gas input flow of some pressure value, of some flow rate, of some temperature. See, for input we are considering three parameters. If required, we can consider more parameters, more manipulated variables. Pressure, flow rate, and pressure value, and temperature. And see, if you apply input to this of this pressure vessel, there is a restriction. This is called restriction. We are provided restriction by representing capital R. Capital R represent that is a small restriction. Prove that the gas input is entered into the pressure vessel. It's a opening. It's a opening. Small opening. Small opening will restrict the gas flow rate. Gas flow rate. Restriction refers to resistance. Understand? Restriction refers to resistance. That's one element. And when the gas is entered into the vessel, closed vessel, inside the vessel, the pressure level is rises. The pressure level is increases. Increases. So what is the pressure value inside the vessel? That is other parameter. What is the pressure value inside the vessel? We have to measure it. Then one more, because the pressure vessel occupies pressure vessel having some large surface area. See, this is a surface area, closed surface area inside it. So inside the pressure vessel, we have surface area. So whenever there is a surface area, you recall that there exists some capacitance. There exists some capacitance. That capacitance is represented by capital C. You have to consider the second parameter is capacitance with the inside the closed vessel of the pressure vessel. So we have two parameters again, resistance and capacitance. Understand what is C and what is R? C nothing but the capacitance available in the gas. And what is R? The resistance
Gas.
of the gas, which is from restriction. We are considering from restriction. Fine. Okay, by taking this example, we are writing this relation. See what the relation? Rate, rate of gas storage in vessel. Rate of gas storage in vessel equals to rate of gas inflow. అంతే కదా ఎంత ఫ్లో రేట్లో నువ్వు ఇన్పుట్ ఇస్తే అంత ఫ్లో రేట్లో గ్యాస్ స్టోర్ అవుతుంది అంతేనా నువ్వు తక్కువ ఇస్తే ఎక్కువ స్టోర్ అవుతుందా నాట్ పాసిబుల్ సో వీఆర్ రైటింగ్ దిస్ రిలేషన్ రేట్ ఆఫ్ గ్యాస్ స్టోరేజ్ ఇన్ వెసల్ ఎంత స్టోర్ అవుతుంది ఈజ్ ఈక్వల్స్ టు రేట్ ఆఫ్ గ్యాస్ ఇన్ఫ్లో ఎంత ఇస్తే స్టోర్ అవుతుంది గ్యాస్ ఇవ్వకుండా గ్యాస్ కావాలంటే వస్తుందా రాదు సో వీఆర్ రైటింగ్ దిస్ రిలేషన్ and mathematically we can write C d P naught by dt. In terms of time point of view, we are writing as per time point of view, we are writing C d dp by dp naught by dt. C dp naught by dt equals to Pi minus P naught by capital R. This is the relation we represented. From this, take some simple calculations. We can write C dP naught by dt equals to, so P naught by PR is in the right side. You take into the left side, you can add P naught by R equals to PA by R. Okay? Multiply the whole equation by capital R. You can get capital RC into dP naught by dt plus P naught equals to PA. For the whole equation, apply the Laplace transform. P naught, okay, Pi of S, we can write Pi of S equals to P naught of S plus RC S P naught of S. If you take as common P naught of S, Pi of S equals to P naught of S into RCS plus 1. You know, as usual, you consider time constant T equals to RC. We can replace RC by capital T. We can write Pi of S equals to P naught of S into Ts plus 1. Ts plus 1. And represent output by input. P naught of S by Pi of S, which is nothing but transfer function, can be represented 1 by Ts. Ts plus 1. I'm sorry. There is equal. There is looks like equals to, but it's not equals. 1 by Ts plus 1. 1 by Ts plus 1. Okay, represent the above transfer function in terms of block diagram. So block this block diagram having a transmittance or gate. For this, input is PA and output is P0. So from this block diagram, what we are expecting, the P0 depends the output pressure inside output pressure of gas depends on input pressure of the gas plus transmittance from the transmittance. So this is the way we can represent the gas system into mathematical models. Okay, next month. Next, Kamali, next slide, ma. Next slide. Okay. Okay.
The next
కనిపిస్తుందమ్మా నెక్స్ట్ కొంచెం పైకి వెళ్ళి ఇంకో స్లైడ్ ఉంది ఇంకో స్లైడ్ పైకి వెళ్ళమ్మా ఒక స్లైడ్ ఉంది
సెల్ఫ్ రెగ్యులేషన్ కాదా సార్
అదే దానికి ఇంకో స్లైడ్ ఉందా చూడు ఓకే leave it ma leave it okay leave it okay no show me that self regulation I want self regulation
liquid level systems with interaction sir
okay self regulation
sir what regulatory control ఉంది sir
yeah this I want okay keep it that పూర్తి చేసాము కంప్లీట్లీ చేసాము okay shall we see this remaining by the evening class okay ఈవినింగ్ చూద్దామా మిగతా క్లాసులు ఇప్పుడు చాలా Dear students, can I proceed or can I stop?
yes sir self regulation delay అవుతున్నట్టు
okay okay ma next self regulation what is self regulation self regulation can be understood by considering a simple tank so you take a simple tank having inlet and outlet so when the water is inlet I'm not seeing the slide mark the screen I'm not visible
ఇప్పుడు అవుతుందా సార్
slide నుంచి మరి1 minute yeah yes
sir
okay ma see self regulation can be understood by considering one example you take a same tank water tank having inlet and outlet so when the water is inlet of some fluoride and water is outlet with some other fluoride so what happens when the water is inlet if fluoride is high compared to outlet fluoride water level simply rises yes or no water level in the tank is simply rises. Rises. Rises, right? And when the water is inlet continuously, water outlet is also continuous. Water outlet is also continuous. After sometimes within the tank, you cannot observe water level rises or decrease. You cannot observe this situation. Understand my point? Dear students, understand my point? Somebody will respond. Please respond. When the water is inlet and water is outlet with some flow rates, initially we can observe within the tank water level may be increases or decreases. Depends upon the input flow rate and output flow rate of the water from the tank. Isn't it? But my point is, for the situation after a long time, after some time, inside the tank, you cannot experience and you cannot observe water level within the tank as increases, neither increases or not decreases. So you cannot observe that change of water level within the tank. That situation so called self-regulation. Hello, how can you decrease the water level? How can you decrease the water level in the tank? If I apply flow rate is high, input flow rate is high compared to output flow rate, water level increases. If I decrease the input flow rate and increase the output flow rate in the tank, output water level is simply decreases. Isn't it? Input, నేను పంపించే వాటర్ ఎక్కువ ఉన్నాయనుకో, నేను పంపించే వాటర్ ఎక్కువ ఉన్నాయి, బయటకు పోయే వాటర్ తక్కువ ఉన్నాయనుకో, అప్పుడు ఏమవుతుంది? ట్యాంక్లో వాటర్ పెరుగుతాయి. అలా కాకుండా నేను పంపించే వాటర్ తక్కువ ఉన్నాయి, బయటకు పోయే వాటర్ ఎక్కువ ఉన్నాయనుకో, ట్యాంక్లో లెవెల్ ఏమవుతుంది? తగ్గిపోతుంది కదా. అంటే ఎట్లా the water level depends on input flow rate as well as output flow rate. నేనేమంటున్నానంటే, you fix the water level, fix the input flow rate and output flow rate. Fix the input flow rate, output flow rate. Initially you can observe water level changes inside the tank, but after some time you cannot observe, this point is important, you cannot observe water level in the tank. You cannot observe change of water level in the tank. You observe change. But what you can observe? You can observe that the water level having same level at a defined level. No change, no fluctuations in the level of the water in the tank. That no change or no fluctuations level, nothing but self-regulation. Nothing but self-regulation. ఎవరు కంట్రోల్ చేయరు, ఎవరు మాన్యువల్ కంట్రోల్ చేయని అవసరం లేదు. కొంత టైం తర్వాత ఆ సిస్టమ్ ఆటోమేటిక్గా ఒక లెవెల్కి వచ్చేస్తుంది. దట్ ఈస్ సో కాల్డ్ self-regulation. Self-regulation. Next slide. Okay, see that difference between self and servo and regulatory control. Servo control also called set point change. Regulatory control also called disturbance time. So here we have 2 points, set point and disturbance. Set point means we want to maintain one parameter in the tank. Disturbance means input changes. So when the set point changes, how do you control? In order to get set point as constant, that is the meaning of servo control. And when the disturbance changes, that means when the input changes, how do you make set point is constant? That is called regulatory control. అంటే సెట్ పాయింట్ మారేటప్పుడు నువ్వు ఎట్లా ఏ విధంగా కంట్రోల్ చేస్తున్నావు సిస్టమ్ని, దాన్ని ఏమంటారంటే సర్వో కంట్రోల్ అంటాం. ఇన్పుట్ చేంజ్ అవుతున్నప్పుడు సెట్ పాయింట్ ఏ విధంగా మెయింటైన్ చేస్తున్నాం కాన్స్టెంట్గా, దాన్ని రెగ్యులేటరీ కంట్రోల్ అంటాం. ఓకేనమ్మా, దట్స్ ద డిఫరెన్స్ బిట్వీన్ సర్వో అండ్ రెగ్యులేటరీ కంట్రోల్. నెక్స్ట్ స్లైడ్. Okay, interactive system and non-interactive system. Don't worry about this concept. We have laboratory about this interaction and non-interactive system. If time permits, we see that live this meaning of interaction and non-interactive system. Interaction system means here we have considered two tanks, tank 1 and tank 2, connected on the same line. See, remember tank 1, tank 2. Observe these two tanks. Dear students, please observe the diagram clearly. You can understand. So, this is the tank 1, tank 2. Tank 1 having input flow rate Q bar plus Q, providing some wall. Through wall, water is inlet to the tank. So, in this tank, that water level may be capital H1 plus small h1. This is nothing but water level. We are representing mathematically capital H and small h, water level. And in between tank 1 and tank 2, we have capital R1. See, remember in the tank 1 we have some capacitance C1. In the tank 2 capacitance C2. And in between tank 1 and tank 2, resistance is R1, flow rate is Q. Tank 2, in the tank 2, there is a water level, and outlet is capital R2, and outlet flow rate is capital Q. So these are all, we are defining some parameters for tank 1 and tank 2. For tank 1, we are defining input flow rate Q, level H, capacitance C, and resistance R. Similarly for tank 2. Remember, these two tanks are connected on the same line. Same line means interaction. What is the interaction system? Interaction system means that tank to output flow rate, otherwise the tank to height H depends on valve R1, valve flow rate Q1, otherwise valve head H1. So it depends. The water level in the tank depends on water level in the tank 1. So that is called interaction system. At depend on interaction antaru. Next, non-interaction system. Go slide kellamma. మనం ల్యాబ్ చేద్దాం. దీంతో ల్యాబ్ చేస్తే మీకు ఇంకా బాగా అర్థమవుతుంది. లిక్విడ్ లెవెల్ సిస్టమ్ వితౌట్ ఇంటరాక్షన్. అంటే చూడండి, tank 1 is in the upper side, tank 2 in the down side. The situation arises like this. This is called non-interaction system. So we will see in figure outlet flow from the tank 1 discharges directly into the atmosphere before spilling into the tank 2, and flow through R1 depends on H1. The variation in H2 in tank does not affect. See, this point is important. The variation in H2 in tank 2 does not affect the transient response occurring in tank 1. This type of system refers to non-interaction system. So, if you provide this type of arrangements and this type of conclusion, it comes under non-interactive system. We will see practically this interactive non-interactive system. Okay, next slide. Komali, next slide, ma. Yeah. Inverse response. Inverse response. Actually,
Yes, yes, sir. పెట్టాను సార్.
yeah,
డిలే
okay, ma,
అవుతుంది
okay.
సార్ కొంచెం.
Visible, no problem, visible. So, what is inverse response of the process? Okay, actually, inverse response nothing but hysteresis. Nothing but hysteresis. Actually, see, this is we are showing representing any graph for a system. To take any system, uh, for the system, if you represent that characteristics in terms of graph, like time versus the value output, time versus as a value output, if the input is like this, input is step change like this, step change like this, initial value and final value like this. But actually, from the output of the system, what is the output of the system we are expecting? You tell me as an engineer, what type of output you are expecting? You are all studying the control system subject in the uh, 2 right? But you tell me, if I give a input step change for a control system, what type of output I am expecting? The same. If I apply a step change, expecting step change output in the control side, output side, control side. So, but sometimes what happens, we cannot expect the actual output compared to input side. So, other than the actual output, we are expecting output is like this. See the diagram graph, output is slowly, initially it is flat and it decreases and showing smooth curve towards a saturation, towards a saturation. So this is nothing but output of any system. This this response nothing but inverse response. Inverse response. Inverse response means it is not the actual response what we are going to expect. It is the response having some error, having some error. That type of system, that type of response also called inverse response in the process control. In the process control. Okay. So actually, whatever output you are expecting no error, no error. At least acceptable error, acceptable error. 0.02% error or 2% error, 1% error. That is acceptable. But 98% output you are expecting from any control system or any control process. Right? Next, next slide. I think this is the last slide.
Yes,
Over.
sir.
Formally, over, ma?
Yes, sir.
Yeah, yeah.
Over,
Okay,
sir.
dear students, this is your first chapter, complete first chapter. If you want any topic as revision or any explanations or any doubts,
అయిపోయింది సార్, ఇంక
you
లేవు సార్.
okay,
ఎస్ సార్.
అమ్మా మీకు ఏమైనా డౌట్స్ ఉంటే దయచేసి నాకు నన్ను అడగండి, మీకు చెప్పిస్తాను. ఇంకో విషయం, మీకు ఈ మొత్తం ఇదంతా కూడా నేను ఒక బ్లాగ్ క్రియేట్ చేసి మీకు యూట్యూబ్ లింక్స్ ఇస్తాను. యూట్యూబ్ లైవ్లో కూడా ఈ వీడియో క్లాస్ మీరు వినొచ్చు. ఓకేనమ్మా డియర్ స్టూడెంట్స్, మీకు ఈ కంప్లీట్ వీడియో క్లాస్ ఇదంతా కూడా మీకు యూట్యూబ్లో ఉంటుంది, నేను అప్లోడ్ చేస్తాను. మీ దాంట్లో మీరు చూసుకోవచ్చు. యాబ్సెంట్ అయిన వాళ్ళు తర్వాత వినాలనుకున్న వాళ్ళు మీరన్నీ కూడా తర్వాత మీరు యూట్యూబ్లో వినండి, డౌట్స్ అడగండి, అన్నీ మీకు చెప్పిస్తాను. ఓకేనమ్మా? ఓకే. యూ హ్యావ్ ఎనీ డౌట్స్?